the video, Andy.
Okay, so we're going to be talking about integrals as limits.
We love integrals as limits.
Mr. Tohak loves integrals with limits. Yay! And we are going to be using the definition of the definite integral to evaluate each integral using limit notation. So just like how we did derivatives with a limit notation, we have integrals with limit notation here. And before we do that, we need to talk about the summation notation in terms of these four formulas right here, which you can read. What we are going to do is actually find the area of 4x from 1 to 5 using geometry first, so that we can better understand how we are getting our answer here, and then using my summation. Looking at the trapezoid, we have 1/2 height, base 1 plus base 2. Our height is going to be 4 because that's just based on my width right here. My base is gonna have a length of 4 and 20. So that's going to give me 1/2 times 4 times 24. 1/2 times 4 is 2. 2 times 24 is 48. So this tells me that I have an area of 48 under 4x between 1 and 5. And what we're going to do is use the summation formulas that we have above to help us evaluate this limit right here as n approaches infinity. I'm going to go ahead and make this a little bit prettier by multiplying the 4 so that I have something like this. Then I'm going to take out the 16. Oops. You want to make sure that we still keep the limit notation just like how we did with the derivatives. So if you don't keep the limit notations, it is wrong. So do not drop them. I'm going to take out the 16 and put up front. And then I'm going to go ahead and multiply using the distributive property to get 1 over n plus 4k over n squared. Once I do that, I am going to break up my summation into 2 parts. And what I'm also going to do is bring out anything that doesn't deal with k, because my summation deals with k. So now I have 16. The limit as n approaches infinity. 1 over n, k is equal to 1 to n, plus 4 over n squared, k is equal to 1 to n, and then k. Of course, this is 1. Now, my summation here from k is equal to 1 to n represents this right here. It's a constant. So we know that that is just going to be n. So I have 1 over n times n, which eventually will give us 1 for the first summation. My second summation, where we have k as a variable, that is going to be n times n plus 1 over 2. So now I have 4 over n squared, n plus 1, all over 2. I'm going to clean this up a little bit. So I have 16, n approaches infinity.
Clean it up.
Yep, clean it up. Cancel out the n squares and the n. So that means that I am left with, and cancel out the 2. So I am left with 2 on top, and n plus 1 on top, and then I'm left with an n at the bottom. Okay, I am going to make this even prettier by bringing the n
Very pretty.
Very pretty. By substituting in n over n as 1, so that I get one fraction right here. And then I'm going to simplify the numerator to be 3n plus 2 over n. And then if I were to break that apart, I know that's going to give us 3 plus 2 over n. And we know that as the limit as n approaches infinity of 2 over n, that's just going to be 0. So the only thing that we really have is this 3. And then we have the 16 right here. So 16 times 3 is 48. So that's what you would do in terms of finding the area under the curve using limits, which is, of course, you could see a lot of fun. It took up the whole page and only gave you like a little bit of room. So, sorry. Yikes. So that gives us 48. All right. So for number 2, we want to find the area under the curve between 0 and 2 of x squared plus 10. And remember that that little drawing is basically this right here. Problem is, I can't really take I can't do geometry in terms of area just because this is a curve. So unfortunately, we can't really do what we did here on number 1, where we found out that the geometric area was 48, and then we verified here. Instead, we're just going to straight out do it using limits and summation notation for number 2. And this was from the past video in terms of what we did. Now, as a reminder, this video is before FTOC. So, if you watch this before FTOC or after, I don't know which one, you could use a little shortcut, but make sure that you do understand the process of this. So that on the quiz or on the test, if we tell you to find the area using the limit definition, then you do this, which gets messy. So you might have a problem where you do it, but not, 80 of them. First thing that I'm going to do is clean this up a little bit. Once again.
Clean it up.
Yep, clean it up. Where we have 4k squared over n squared plus 10, and then 2 over n. Then I have the limit as n approaches infinity of 8k squared over n cubed plus 20 over n. Okay, I am going to break my summation into 2 parts. And I am going to bring anything that is not a k up front, so that whenever we do our summation, what we are... Oh my beauty, Kevin. What we are substituting in. So for the first one, we have the summation of k is equal to 1 to n of k squared, and that's going to be this lovely formula right here. n plus 1, 2n plus 1 over 6. I know, crazy. Oops. So we have that. And then, since this is just 1, it just becomes n. So now I have the limit as n approaches infinity of 8 over n cubed. N plus 1, 2n plus 1 over 6, plus 20 over n times n, which eventually, the n's will cancel out, so you're left with 20. All right, that left side looks like a mess, I know, bear with me. We are going to simplify the 8 and the 6 to get 4/3. We're also going to simplify the ends. So an n and n cubed will give us an n square. And then we still have the n plus 1 and the 2n plus 1. All right, we have to multiply out n plus 1 and 2n plus 1. There's no way to get around that in terms of what we need. Well, honestly, you can. Because honestly, here, I don't really care about this because either way, this is going to be an n square. And if I have an n square and an n square here on the top and on the bottom, and we are approaching infinity, remember that since they're the same exponents, we could probably just look at the leading coefficients. So the leading coefficients for the numerator is going to be 8. And then the leading coefficient for the denominator is going to be 3. So honestly, this limit right here is just 8/3. This limit right here is 20. And then if you add them together, you're going to get 20 and 8/3. Or if you're feeling spicy and you want to simplify it a little bit, you could get 68/3. And that, folks, is number 2, which wasn't that bad. Number 3 is essentially the same process as number 2, where you have 5x squared minus 2x. So you guys can do that. And I'm going to cheat a little bit and use FTOC so that I can give you the answer, because I am kind of lazy to do this tonight. I know. Your answer should be 36 once you do it using the long way. Of course, once we get to the lesson on FTOC, you can use our little shortcuts, but as of right now, we don't know that yet, so we have to, unfortunately, evaluate the integral using limit notation. Very fun.